Alright, so in chemistry and in some of your other sciences, you're going to work with some huge numbers and some small numbers. Alright, this also relates to significant figures because when you have numbers like these, generally you have, maybe 3 or 4 sig figs and then the rest are all zeros. So scientific notation is a way of abbreviating those numbers. So, for example, in this class, we are going to deal with the mole equaling that number. Okay? It's 6 followed by 23 places. Okay, so it always goes 602, but then after that it's all zeros. It's much simpler to write this out as 6.02 times 10 to the 23rd. It's a lot shorter. You don't have to sit there and count all your places. Alright, and then eventually I'll teach you how to plug this into the calculators. Okay, so it saves time because your calculator wouldn't even accept this many digits. Okay, sometimes we also deal with some very tiny numbers. Alright, like the mass of an electron. This one, I actually have to count to figure out how many zeros there are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, this is 9.1 times 10 to the negative 32nd. Alright, so much simpler to write things in scientific notation, especially when they get to this scale, but it also helps remove the insignificant figures, alright, because zeros to the left are always what? Hopefully you said insignificant. Same thing, zeros to the right, as long as there's no decimal, those are insignificant as well. So scientific notation makes it so that we only write the significant digits. So, what's even more complicated is attempting to actually do something math-wise with these numbers when you have that many zeros. Alright, I'm not going to make you do this stuff by hand. I'm fine with you using calculators, but even still, trying to type in, 31 zeros or 22 zeros, it's just silly. Alright, it's much easier to type in scientific notation into the calculator. So, scientific notation always has this format. There's m, which is some number that's greater than 1 but less than 10. Alright, it could be 1.234, 9.678, alright, but some number. And then we multiply it by 10 to the something, alright, where n is any sort of integer. Now, n can be positive or negative. And that does imply something. We'll talk about that. So, first thing that you do is put in the decimal point so that you can see where it is. Alright, it wasn't here to begin with because we know that these zeros are insignificant. So I put this decimal in. Alright, second step is deciding where the decimal has to go. We want to make it so that our scientific notation is a single integer with a decimal point followed by any other significant digits. Alright, so in this case it's going to be 2.5. Then step 3 is actually figuring out how many decimal moves it takes. So 1, 2, 3, 4, 5, 6, 7, 8, 9 moves. And then we rewrite it in our format. Alright, m comes from step 2. It's going to be the 2.5. Alright, and then we're going to write times 10. And then little n is the number of decimal moves. Okay? So, we write it like this. 2.5 times 10 to the 9th. Alright? The exponent is always going to be how many times we move the decimal. Alright? If we're moving the decimal left, it stays positive. Alright? Or essentially, if our number, this is probably the easier way to remember it, if the number was greater than 1, exponent is positive. is for a smaller number. All right. Again, this time we don't need step 1 because the decimal's already in there. All right. So step 2, we have to figure out where it's going to go. We want one integer in front of the decimal, and then all the other significant figures go to the right side of the decimal. All right. And then we figure out how many times we're going to have to move the decimal to get it there. 1, 2, 3, 4, 5. And then we rewrite it in our m times 10 to the nth format. Alright, so it's 5.79 times 10 to the, this time it's going to be -5. So the -5 comes from the fact that the number we started with was less than 1. Okay, so if the number we start with is greater than 1, that's a positive exponent. If it's less than 1, negative exponent. Okay? Just a little bit more practice. See if you can do it before I do. But this one, we don't have the decimal, so I'm going to do step 1. I'm going to draw the decimal. I want to move the decimal there. Then I'm going to go 1, 2, 3, 4, 5, 6 moves. So it'll be 2.5 times 10 to the 6th. Okay, 1, 2, 3. Alright. One more negative one. So this time decimal's already written for me. I don't need step 1, but step 2. I want to show where my decimal point's going to go. Alright, then I count 1, 2, 3, 4, 5, 6, 7. Then I rewrite it in my m times 10 to the nth format. So 5.6 times 10, and since it was 1, 2, 3, 4, 5, 6, 7 moves, and our number started out less than 1, it's -7. Okay? So, another thing that I'll have you practice just to kind of get this down is taking it out of exponent form. Alright? So, to do that, you just set it up, your 2.34. Alright? And then if it's a positive exponent, we're going to move our decimal so that we get a number greater than 1. Alright? Which should be to the, hopefully you just said right. So you just move it to the right 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of these get zeros. Alright, and we have, let's see, that gives us, get my commas in there, 2,340,000,000,000,000. Okay, it's a lot shorter to write it this way, but just so you know what the numbers mean. If you can move them back and forth both ways, you know what you're doing with scientific notation. Alright, and one with a negative, so again, we write out the number, 5.32, and then since it's a negative exponent, we want to make sure that our answer is less than 1. So this time we move the decimal to the left, so 1, 2, 3, and we fill in zeros, so this is 0.00532. Okay, so please do the online assignment, and I will see you in class, and bring your notes. One last thing. Sometimes computer formatting does not allow for the superscript notation. So you may also see scientific notation written something like this. 5.2 times 10, and then the little caret symbol, -3. Alright, that's the same thing as 5.2 times 10 to the -3rd. Okay, just a heads up. when, depending on the program being used in class, you may see it written as the superscript, or certain things will require me to type it as the caret notation. Okay?